Action.
Good morning, students. First of all, I would like to introduce myself. My name is John Yate. In short, you can just call me Mr. Yate. I'm a specialist in mathematics. Of course, I started teaching since 1982. And up to this time, I'm a teacher. I'm a whole head of department in one of the renowned schools in the Gambia. And, because of the experience I've gathered over the years, I thought it is necessary for me to share so that at least for teachers who are just coming up, who have not got much experience in teaching, by the time they watch these videos, this will give them more experience, especially teaching mathematics. And over and above all, I think it is also very much important, especially to the student. Now, there are students who are not in the city here. Some of them stay far away. Accessibility to information is very, very much difficult. And I know in some of the schools, especially up countries, they don't have very good teachers, very experienced teachers. In fact, in some schools, you don't have a teacher at all. But I'm sure with the help of this video, if you have this video, whichever part of the Gambia you stay, you can always use it over and over to be able to understand so many things. It is designed purposely for Gambeka, okay, and with the WAS exams. So both of these students can have the time to look at this video over and over and over, and I'm sure it will help them greatly. All right? So without wasting time, the first topic I would like to do today is going to be trigonometry. This is one of the topics that teachers sometimes find it a bit difficult to explain to students for them to understand. So this is the more reason why I thought it necessary maybe to start with it first, so that at least it can go a long way to help students who might not be able to understand it in the normal school lessons. All right, so students, I expect you to pay attention. I will do all the explanation. At the end of the lesson, you can ask your questions, and I'm sure I should be able to, answer your questions. So like I said, the first topic is trigonometry, and if you can see the subtopic there is talking about trigonometric ratios. Now, in the first place, what is trigonometry? Trigonometry actually has to do with the relationship between the sides and the angles of triangles. To be more specific, it must be a right-angled triangle. And we all know that a right-angled triangle is a triangle in which one of the angles is 90 degrees. So mostly for trigonometric ratios, you can only apply trigonometric ratios in a situation where you have a right-angled triangle, all right? So before going deeply into the topic, let's take the next slide. We are going to look at certain objectives of the lesson today. Like you can see, at the end of the lesson, students should be able to understand how to identify the sides of a right-angled triangle depending on the given angle. So I want you students to actually understand, first of all, before we even go to trigonometry itself, you should be able to identify the sides. What do I mean by that? You need to know which side is the opposite. You also need to know which side is the adjacent, and you also need to know which of the sides is actually the hypotenuse. So that is what I mean by identifying the sides of a right angle depending on, of course, it depends on the angle, because sometimes the naming of the sides changes. It depends on what angle you are talking about. But I'm sure I'm going to deliberate more on that as we get along. The second objective is the three basic trigonometric ratios. Of course, we are also going to talk about the three basic trigonometric ratios, which are very, very much important. These are the ones used to actually solve, let's say, if you want to find the side of a right angle triangle or the angle of a right angle triangle. So you always use the trigonometric ratio, so I also have to talk about it. And the third one is how to find missing angles in a right angle triangle using trig ratios. I think that is just what I've just spoken about. Okay? When you know all these trigonometric ratios, how can you apply these trigonometric ratios in finding the sides at the same time finding the angles of a right angle triangle? Precisely that is what we are going to do. So let's start with the first objective, which says that we need to identify the sides of a right angle triangle depending on the given angle. Now, of course, what you see on the board is a right angle triangle. It is a right angle triangle because you can see that one of the angles is 90 degrees. This symbol actually represents a right angle triangle, all right? And I said in the objective that depending on which angle that they are talking about, we'll be able to, sort of define the various sides you have. For instance, we are talking about this angle. If we are talking about this angle, directly, this is the opposite side. You can see that this is the opposite to it. And you can see that the side which is very, very close to the angle is what we call the adjacent. The hypotenuse is always the longest side, and that is the side which is opposite to the right angle. So you have to understand that, okay? So one thing you have to learn here is any side which is very close to the angle, it is always the adjacent. And any side which is directly opposite to the angle is always the opposite side. And of course, you have the hypotenuse, which is always the longest side, and which is the side that is opposite to the right angle. The reason why I am emphasizing this point is because you cannot have the triangle always in this shape. Sometimes they turn it upside down. So no matter how they turn it, all you have to do is see where the side which is opposite to the right angle. Also try to identify the side which is very, very close to the angle, which is the adjacent, and also try to identify the opposite side. It's very, very easy because once this is my angle, I know this is the opposite. In case this was the angle that they are talking about, in case, just a minute, let me take the marker and tell you something. Suppose we would have talked about this angle. If you are talking about this angle, this is no longer the opposite. But what do you think the opposite is? This now becomes the opposite. And obviously, this side, which is very close to the angle, now becomes the adjacent. So that is why I stated in my objective that it depends on which angle you are talking about. But specifically for this one, because we are talking about this angle, so definitely this becomes the opposite side. And the side which is very close to it becomes the adjacent. And this becomes the hypotenuse, which is the longest side, and which, of course, is the side which is opposite to the right angle. All right? I hope that is clear. Yes, let me give some few examples here to see how best you can be able to identify the sides. All right? Let's say we have a right angle triangle like this. This is a right angle triangle. All right? I can even give it a name. Let's say this is A, this is B, and that is C. So once you have this, if I'm talking about this angle, let me see whether I have a red marker. Oh, not at all. If I'm talking about this angle, then student, can you tell me exactly what is the opposite side? The opposite side of this is this. This is the opposite. All right? And as long as this is the opposite, this becomes the adjacent. Why is it the adjacent? Because it is the side which is very close to the angle. Why is this the opposite? Because you can see that it is directly opposite to the angle that they are talking about. And of course, this is always the longest side, which is the hypotenuse. And it is the side which is always opposite to the right angle triangle. So you see how I have actually turned the whole right angle triangle into another shape. Sometimes they can even draw it like this. They can even draw it like this. They can draw it like this, and they will tell you this is A, and that is B, and that is C. And now they will say this is the angle that they are talking about. So if they are talking about this angle, obviously this becomes what? Of course, the opposite. This is the opposite. And what can you say about this line? It is the adjacent. Why adjacent? Because it is the one which is very, very close to the angle. So this is the adjacent. And this one becomes the hypotenuse. And why is it the hypotenuse? Because it is the longest side, and because it is the side which is opposite to the right angle.